So this is a very simple circuit, but now the one which I showed before is a simple circuit, but now we are going to do a very complicated circuit. So let's start. So this is originally a normal circuit but almost as a complicated one. Here we have the resistor, a light bulb and a one more. So here we can adjust if it's conventional or electrons. We can even ask if we can show the current or not. So now we are going to connect them with this wire. I know you all might have think that it is very common. You know, in in companies they originally don't use this, but in schools to make children learn, they use these to improve their circuiting skills, like subjects like Atal. So I found this website when my teacher told about a circuit. So now all the electricity is flowing through all of these. Now, because this is only 9 volts of power, but now if we delete and switch it to this one, it is very powerful and consists of many. So because of the power, it is over the light bulbs and resistors are very overloaded. So we can just increase the power of the resistors, but even with 120 ohms it is not enough. So we'll delete it, use a bigger resistor that is fit for that, and use this. Now as you see, it is not flowing very fast here, but the battery is very fast. So decrease the voltage and ma. So now we have decreased the voltage to 200 volts, and the resistor power is 1000 ohms. So let's decrease. Due to this, now now the power of the resistor is 200 ohms. So now we will just keep it carefully so that it doesn't do anything. But now just because I removed this circuit, it stopped entirely, because this circuit will connect to this and this by going from here, and from there it will go there. Even when it comes to here, it will go from here to here again. So that's how this is. And now let's try to keep a fuse. By removing the resistor in the resistor's place, I am keeping a fuse. But due to the fuse's rating, it is very poor. So I have to increase it to 20. But that is also not enough. Now let's do this. And it survived. So, but still the battery voltage is too much. So I decrease it to 100 volts. Now everything is running smoothly. But if we remove the fuse, it it is not using the fuse, and it is going through these two light bulbs. Now if I again keep the fuse by connecting these both, the fuse isn't working because the input is too much powerful. So we disconnect this and use this and connect it again, but still it doesn't work. So we have to, because the rating is still at 4.4, so increase it to 120. So now it works. Start connect it again, and now it starts working. But when you use the bulb, it doesn't work. When you turn the switch off for the fuse, then the electricity flows to the bulb. So this is how this circuit works. Now let's make another one. Now this is a very simple circuit. Using a battery, we can make very much things. So let's go down. We have a coin, an eraser, a paper clip, and a dollar bill. So we will see, and one more is also there, a pencil. Now we will see which one can transmit energy to from the battery and through, and again through the battery again. So let's start. We are doing this and again. But the paperclip can transmit electricity, but it is just too fast and the battery cannot hold. So by deleting this and we keep an eraser, well, obviously it doesn't work, because eraser is er, eraser is made of rubber, which cannot transmit energy. So we're deleting that and keeping a coin. Will it pass? Yes, because it is also made of metal, some kind of metal. So now again the battery overheated, just because the power is too much, even though it's just 9 volts. So we were keeping it reverse and again reverse. Now we will just disconnect this. Keep and keep a resistor. Now the power is slow but working. Now Now we know that this is a electricity transmitting item. So let's keep it here. Now we'll take a dollar bill. Will it transmit? No, it's because it is made out of paper. It does not transmit energy to it. So this is the thing in just lines. But we are going back to the fictional, and now it doesn't work. So let's use pencil. Obviously, pencil can transmit energy. See, but if we just remove the resistor, keep it still doesn't pass as good as we know, because it is made out of thick materials. So that's why even if we increase it to 120 volts, it does not go as fast as we thought. So we're deleting this battery and keeping a much more powerfuler battery. But now the pencil and it are, are burning just because the battery is at 1000 volts and the pencil cannot hold this much power. So we are decreasing to 100 volts. We're going higher and higher and higher, and from from 380 volts it starts burning because a pencil can hold 370 volts, but it cannot hold 380 volts because this is a very powerful battery. So now that's all, and now we are going to do a newer one. We are going to zoom zoom out. So we have these are the things we have in feet circuit construction kit DC of feet: wires, light bulb, resistor, switch, a fuse, powerful battery, light bulb, a powerful light bulb, powerful resistor, wire again. We don't need it. We have $1 bill, a paper clip, a coin, an eraser, and last but not least, a pencil. These are the only things we have in feet. These are the things we have. So let's assemble the batteries and the resistors, wire, and other and the thing which transmit energy through them. Through them are these items. The things we do not transmit are these, and light bulbs, of course, here, and switches here, fuses here. So these are the things we have and which work. These are the things which work in feet construction kit. So that's all for today. Bye.